study. All right. The coordinates of the vertices of a triangle are blank, blank, blank. I want you to go ahead and plot those on your paper right now. Everybody plotting, you can use your ID card as a straight edge. There are rulers over there underneath to be the difference sign if you really, really want one. But you're plotting and graphing, or connecting. And make sure you're labeling them A, B, C, and so forth. Bless you. All right, do you guys have it looking like this? Yep, yes. Yes, did your ABC look like this? Okay. What does part A ask us to find? I want you to read that to yourself right now. Part A, you're reading to yourself. Okay. How many midpoints are we finding? Two. What are they asking us to name the two midpoints? D and E. So not only do you need to find them, but when you need to plot them and label them. Okay, they want D to be the midpoint of what line? AC. I wish I had spaced this out just a smidge bit more because that is very little. So I'm going to write down, and this is what I want you guys to do on the test as well. Some of you did it on the quiz, and I thank you, and some of you did not, and it was really hard to grade, and I will not be making that effort on the test. So you want to make sure that you are neat and clean. So A and C. Why am I labeling A and C? Because those are the 2 points I'm going to use to find midpoint D. So A is 4, 6, and C is 0, 0. And yes, you label them. Why? Because when you get a wrong answer, and I go to check your work, it's easy for me to see what points you used. Did you mess up on the points you used? Did you plug them in the wrong way? If you don't have the points you plugged in, I can't, it's hard to tell. Okay, so midpoint formula is what? What do we do with the x's? Add them or subtract them? Add them. 4 plus 0, and then we cut them in half, and then 6 plus 0 divided by 2. What's 4 plus 0? 4 and 4 cut in half? 2. 6 plus 0 is 6, and 6 cut in half? 3. All right. You box that in. If you have a highlighter, you highlight it. Something, bubble, box. You have to do something so that when I'm grading, I can see it, because this is a mess on the test. There's all this work, and there's no answer columns over here for you to put your answers. So I need to look through all of your work to find your answers. Box them, bubble them, circle them, highlight them, something. Got it? Okay. Now, am I done with part A? No. Well, I'm done with the midpoint D, but what other midpoint do I still need to find? E. And E is the midpoint of CB. So again, you label the points you're working with. And thank you again to those of you that did it. Those of you that did not, make sure you do it exactly this way on the test. You label C, you label B. C is 0, 0, and B is 6, 0. And we're going to label this midpoint what letter? E. And I want you guys to go ahead and try that now. Add your x's, divide it by 2. Add your y's, divide it by 2. All right, you guys get an answer? 3-0. Okay. You don't have to highlight them. I'm doing it only so that it's easy for you guys to see. But you do have to box them in. Box them, bubble them, circle them, do something so it's easy to find when I'm checking your work, when I'm grading it, not just checking your work, when I'm grading your test. Okay, we do have to plot them over here. If you don't plot them over here, you do get docked points. Okay, so 2, 3. I go over 2 and up 1, 2, 3. I plot it, and that is point D. 3, 0. I go over 1, 2, 3, plot it, and that is E. Now, if D is the midpoint of CE, what does that mean about CD and CD and AD? These are what? You're a step ahead of me. Okay, so these two are congruent. Do you agree? What does that mean about CE and BE if E is the midpoint? Congruent. Okay, now I'm going to connect and address what Peyton just said. What do we know about DE and AB? We're about to prove it in the next step. They're parallel. Okay, we also know that AB is how much bigger? 2 times. We're going to prove that in part C. Okay, so right now we're about to prove that they are parallel. What formula do I use to show that lines are parallel? Slope. Mark that, star it, do something, because you need to know that on the test. You can't be taking the test tomorrow and ask, how do I show lines are parallel? I cannot answer that. So right now I'm asking you, how do you show lines are parallel? Slope. Now you either look at the graph and you measure rise over run, or you use the slope formula. I'm going to use a slope formula. DE is parallel to AB, so I'm using DE first, so I label D and I label E, because those are the points I'm going to use to find the slope of DE. Where are DE? Given or the ones I found? Okay, so 2, 3 and 3, 0. And do you need to know the formula for the slope? What goes at the top, the y's or the x's? X, y's, not sure? Here's one way to think of it. What do you guys use, like the run and the rise? How do you say it? Rise over run. One part should rhyme. Y's over x's. Rise over one. Rise over run. Y's over x's. Rise and y's go together. If you flip-flop them and put x's over y's, is any of it going to rhyme? No. So remember the top rise with the y's. Got it? Yes? Okay, so what goes to the top, the y's or the x? Okay, so y2 minus y1, x2 minus x1. Do you need to have that formula memorized? You do. Now, how many of you don't use the formula and you just count rise, like down and over, rise over run? And that is fine, but do you have to label how you're doing it? I counted the rise over run on the graph. Okay. So what does that give me here? 0 minus 3. That's here. 0 minus 3 for the y's. And what do I do for the x's?
3 minus 2.
3 minus 2. Thank you. 0 minus 3 is negative 3 over 1. Is that the same as negative 1/3? It is not, so you want to make sure you write it negative 3 over 1. All right, now what am I going to do again? Same formula, but this time for what line? AB. So now I'm going to label A, and I'm going to label B. And A, B, we're given information. A is 4, 6. B is 6, 0. And again, this is how I want it on the test. You label all the points you're using every single time, over and over. Okay. Slope. I'm going to do 0 minus 6. Do you guys see where that's coming from for the y2 minus y1? What will I do for the x minus x? 4 minus 6 or 6 minus 4?
6 minus 4.
6 minus 4, thank you. And that gives me negative 6 over 2. And kids are like, oh, wait, they're supposed to equal. Why don't they equal yet? Because I have to divide top and bottom by 2. What's negative 6 divided by 2?
Negative 3.
And 2 divided by 2?
1.
Do they come out to be the same?
Yes.
Okay. Now, how many of you are just counting rise over run? You said you were? If you do that here, and I looked for them on the quiz, for those of you that were, when you count your rise over run, you're not going to end up with negative 3 over 1. You're going to have 1, 2, 3, 4, 5, 6 over 2. So should I still see this fraction on your paper? Yes, this is you showing me work. You show me the original fraction that you counted and then what it reduced to. These are the 2 you box in. This would be the work you're showing. And then, of course, a little written explanation. I did rise over run for my graph. Okay? All right. Mathematically show the length. Oh, before I go further, did we just prove that the 2 lines are parallel?
Yes.
Yes. Okay. Now we're going to show that AB is how much bigger?
2 times bigger.
2 times bigger than DE. Okay. It says half here. Is that the same thing? Is DE being half of AB is the same as saying AB being twice as big? Okay. So we're going to find DE, or the length of DE. So I label D and I label E. And what is D? 2, 3. And what is E? 3, 0. And I've run out of room, so I'm going to put it down here. Do you guys remember the distance formula?
The simple thing.
The square root thing?
Yeah.
Okay, so remember the skeleton we've talked about? If you can remember the skeleton, the rest of it can kind of fall in. What goes in here? Big parentheses,
X minus X.
squared, you're a step ahead of me, and then plus big parentheses squared. So yes, you're filling in, and I'll ask for that in just a second. Do you guys agree this is what the skeleton of it looks like? Quantity squared plus quantity squared. And then what did you say goes in here?
X minus X.
Good. So x2 minus x1, and then y minus y. All right. Do you need to have this formula memorized?
Yes.
Yes.
On the test you said we could use the note.
Ooh, I did not say that.
Oh, the quiz.
The quiz. And I said you will not be able to on the test. Okay, so this one, there's no way around it. There is no, oh, I eyeballed it, I looked, I counted. No, you need the distance formula. Unless you remember how last year how you used the quadratic formula, which some of you did. If you remember, you can do that. But in the end, it's still the distance formula. Got it? Okay. Distance equals skeleton, big square root, quantity squared, plus quantity squared. Remember that piece, and then fill in the meaty pieces after. X minus X, I'm right here. Do you want to do 2 minus 3 or 3 minus 2? It doesn't matter.
3 minus 2.
3 minus 2, let's keep it in the same way as the slope. And then I'm going to do 0 minus 3. What is 3 take away 2? 1 squared plus what 0 take away 3? Negative 3 squared, big square root still. And what's 1 squared? 1 plus what is negative 3 squared? 9. So I have 1 plus 9, which is, so what's my answer here? Square root of 10. Now, I think the answer came out very similar on the quiz. Kids try to break down root 10. Does root 10 break down into prime factors? Or does 10? Yes. Can you break 10 down?
No.
I'm sorry. Yes. Okay. So 10 breaks down into what 2 numbers? 2 and 5. Now, in order to come out of a square root, what does it need to have? A pair. So I had kids do this. Oh, that's 2 root 5. Is that correct?
No.
No. 2 times 5 has no pair, so it just stays as root 10. And you write it as root 10. You don't write it as root 2 times 5. Root 10 and you're done. Got it? Okay. Now, what's the next piece we have to do? Compare it to the length of AB. Now, remember what we're trying to end up with. What is double root 10? It's not root 20.
2 root
2 root 10. Double root 5, 2 root 5. What's double root 7? 2 root 7. Okay, so it's not that you double the number on the inside, you double on the outside. Okay, so we know 2 root 10 is what we're trying to come up, what we should end up with. Okay, what are we looking for the length of now? The length of AB. So we list A, and we list B, and yes, this is part of you showing your work. And you're going to say, well, I listed them up here. Yes, you keep doing it on every little piece all the way through so I can check your work. All right, A is 4, 6, and B is 6, 0. Distance equals skeleton, big square root, quantity squared, plus quantity squared. Meaty pieces get filled in. X2 minus X1, what do I subtract? 6 minus 4, good job. And then Y2 minus Y1 is 0 minus, 0 minus 6. And what is 6 minus 4? 2 squared, plus 0 minus 6 is negative 6 squared. Oh, and that comes out to be 2 squared, 4, and negative 6 squared is not negative 6 times 2. It's negative 6 times negative 6, which is 36. And 4 plus 36? 40. It's okay. And are we done with root 40? No. Now, 10 broke down to 2 and 5 and nothing came out, but 40 breaks down to more pieces. So let's check. What do you want to break it down to? 10 and 4. Neither of which are prime, so 4 is circle because they're prime. 10 is 5 and 2, and those are both prime. So how many 2's do I have? 3 2's and 1 5. Now this is still kind of new to us, and I had a lot of kids ask me last week, do they all come out because they're all 2's? No, we only circle in pairs. So only one pair comes out. Does it come out as 2 or does it come out as 4? 2, because it's 2 times 2 is 4, and the square root of 4 is 2 root, and 2 times 5 is 10. And some kids wrote it 2 root 2 times 5. Actually multiply these together and call it 10. Did it end up being double the way we said it would? Okay. So on the test, what am I going to look for? These two boxed in with you labeling your AC and your CB. These two boxed in either with you labeling the way I did here and your work, or you show me over here you did rise over run. DE, AB, all the work, root 10, 2 root 10, and they're boxed in. Does this make sense? Yes? Okay, questions on this? I would study this tonight and go over and make sure, watch the video again, make sure you can do it on your own. Questions before I move on to the proof? Okay, it's been a while, but we've done this proof before, so we're going to see if we can come up with it again.
We have that the test again?
Yes, yes. And we've done this particular proof we did on one of our packets. Right here. We did it right here. So we're going to do it again. Statement. Okay, given PM is perpendicular to AB. If it is perpendicular, can I put a marking right here? Yes. I will have to say later something about that, but I can mark it. PM bisects AB. If PM bisects, what does that mean about AM and BM? They are congruent. I will have to say that later as well, because it did not say it AM is congruent to BM. Since it did not say it that way, I will have to say it later in my proof. All right. In other words, PM has a special name. PM is the what? Perpendicular bisector. Do all perpendicular bisectors go through the vertex? Here's a perpendicular bisector right here. Does it go through the vertex? No, only when the triangle's what? Isosceles. That's what we're trying to prove right now, that it's an isosceles triangle. We're trying to prove that AP is congruent to BP. So right now we're trying to prove that this is an isosceles triangle. Are we ready? Okay. First thing, obviously, PM is congruent to AB, and PM bisects AB, given information. All right. Any thoughts of what we can take care of this information? We can take care of this information, which I haven't talked about, but we will need to. Yes.
And he said PM is congruent to PM.
Good job.
What's the property?
Okay. So he's saying to start with this piece that I haven't even addressed, but is true. He said PM is congruent to PM because of the what property? Reflexive. Okay. Are we good? Okay. Now, that is correct. Now, I need to address some of these well, before I even go any further, can anybody tell me why eventually these two triangles will be equal?
AM and B are congruent.
Right here, side.
Side and angle.
So I'm going to write that down now. I know eventually it's going to be side angle side. Can you guys tell that from the picture? Okay. So far, I said that this is congruent. I do have to state that these are congruent, these segments, and these two angles are congruent in order for this to work. Okay, what do you want to work with next? The segment down here or the angle measure?
Segment.
The segment. So AM is congruent to BM. And I want you to write down the reason now. And it's not reflexive property. It has to do with definition of something. So we wrote down AM is congruent to BM. Volunteer, give me why that is true. Yes. It is the definition of midpoint, but just be careful. It didn't use the word midpoint up here. It used what? Bisector. Good job. Definition of bisector. Make sense?
Would it be definition of perpendicular?
You could use perpendicular bisector, but it didn't say perpendicular bisector, even though it is. And two, it's not the perpendicular piece we're using, it's the bisector piece. But if it did say PM is the perpendicular bisector, same thing, you really only need the bisector. We're not using the perpendicular piece yet. All right, now what's the last piece before I get to step 5? What do I have to say about these two angles? They are what? If this is 90, do you agree this is 90? So do I have to say the two angles are congruent? Yes. So angle, remember I cannot call that angle M. I need 3 letters with M in the middle. AMP, angle AMP is congruent right side. What shall we use? BMP is congruent to angle BMP. Again, M has to be in the middle if you're talking about these angles here. Okay, and we would say because they're both right angles, and right angles are what? Congruent. Right angles are congruent. Okay, done with the problem? I'm only done with the problem if I ended with what I'm trying to prove. Did I end with what I'm trying to prove? No, I said the triangles are congruent, but what am I trying to prove? And have I proved that yet? I haven't stated it yet. Can anybody tell me? I'm going to write it down. I'm going to write down AP, because that is what I'm trying to prove, and I am ready for it, is congruent to BP. Can anybody tell me, a volunteer raise their hand, and tell me why these two pieces are congruent? Before I get a volunteer, I'm going to have you think about it. I just proved that these two triangles are congruent, and what do we know about corresponding parts of a congruent triangle? Don't say it out loud, just think about it. What do we know about corresponding parts of congruent polygons? Okay, now I'm ready. Who's going to give me what I fill in here? Yes?
Corresponding parts of congruent triangles
Corresponding parts of congruent triangles are congruent. Good job. Correspond, can we use the CPCTC?
No.
No, you should recognize it, but you can't use it. And I think I had somebody use it on the last test. It was a little frustrating. After all the, you can't. Corresponding parts of congruent triangles are congruent. All right. Study this, guys, on the test. Any questions before we move on to the back side? Okay. Back side. ABC has vertices blank, 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 respectively. What does that mean, respectively? That means this first one is what? A. The second one is B. And the third one is, it goes in order from, if this had been BCA, then we'd do BCA. All right. I'm going to have you plot and connect. Go ahead and do that now. Plot and connect. Hello, Mrs. Torres. Quick. Yes. Yes, please. Okay. Okay, thank you. Bye-bye. All right. Everybody have it? All right, does everybody's look like this? Okay, now let's read on. Plot ABC in a coordinate grid, we just did. Draw the median on each side of the triangle to find the centroid of ABC. Label the centroid point D. Okay, what is a median? You guys have to think back. Don't look back at the notes, just think. That's this one here. I'm not going to put it there long enough for you to see. Medians. Do you guys remember what the medians do? Okay, it's the middle of each line. And does it go straight up perpendicular, or does it connect to the vertex? Vertex. Here it is right here. It cuts the line in half, and it goes to the vertex. How do you know it doesn't go straight up? Because if it went straight up perpendicular, it's called the what?
Perpendicular.
Perpendicular bisector. And it's not perpendicular, it's just the median. All right, what formula are we going to use to find the middle of this line, the middle of this line, and the middle of this line? Midpoint. Do we know the midpoint already? Have we been using it?
Yeah.
Yes. What do? We add the x's and cut them in half. Add the y's and cut them in half. Okay. Let's call them x, y, z, just so we have a name for each one. Okay. So I'll call x for the midpoint of AB. And just like on the last problem on the front page, show your work. So I'm going to do the midpoint of A, B. What's the midpoint of, what is point A? Negative 5, 4. What is point B? 7, negative 4. Okay. And what are we going to call this midpoint? Z. I'm sorry, X. And again, it didn't tell us to. We're just trying, so when we're talking, can explain what's what. All right, midpoint. Add your x's together. So what am I going to have? Negative 5 plus what? Negative 5 plus 7, divide by 2. And 4 plus what? Negative 4. Divide by 2. Go ahead and work that out now. All right, what do you get? 2 comma 0. Negative 5 plus 7 is 2 over 2 is 1 comma 0 over 2 is 0. Bless you. All right, 1 0 for point X. All right. Now this would be really nice if you had a straight edge. If you don't, that's okay for now. But I'll be sure to hand them out on the test. Okay, so X, can you see that it does? I mean, if you look at it, you can see where that is the middle. And if you counted like rise over run, you would see that it is the middle. Yes or no? Okay, now I just did AB. I'm going to move on to BC. BC. And I'm going to do the same thing. What is point B?
7,
7, negative 4. And what is point C? 7, 8. And let's call this point Y. Oh, I'm going to box this guy in. I'm going to have you do it now. Add your X's, divide by 2. Add your Y's, divide by 2. And then plot. Yeah, just make sure you sign out.
For this one, couldn't you just count?
If you want, oh yes, because it is a vertical line, he's saying, could you just count? Yes, if you're already doing it, go for it, or count and then check with us in the end. He's saying because this is a vertical line, yes, you can just count your way to the middle. Go ahead and do it now. Good job at catching that. All right. Did anybody plug it in or count? Either way, do you guys have your answer? What did you get? 7, 2. All right. Any questions on how we found the midpoint of BC? Okay. What's the last piece we're going to find? The midpoint of what? Midpoint of AC. And I'm going to have you do that now. There's A, there's C. We'll call this point Z. All right, check with your group members.
What was the 2 parts again? That was
We're doing AC, side AC right now. Check with the people in your group. See if you guys I know, it's because the next step you do. I know. Okay, so now we are going to connect. What does it say? When you read in the beginning, what is the point of concurrency? Does it say what the point of concurrency is? Okay, centroid. Does it say that on your paper? Yeah. All right, so that's what we're going to try to find right now. So we just found all the midpoints. Yes? Okay, so since we found all the midpoints, how do I do it? Do I draw a perpendicular line or do I connect to the vertex? Yes. Okay, so the question I asked was, do I come to the middle and draw a perpendicular line? No. That's the perpendicular bisector. I connect to the what? Vertex. So connect point to point, and you do want a ruler for this, and connect. Do you guys see what I did? I connected my midpoint X to vertex C. I connected my midpoint X, that means these two are congruent, to vertex C. I'm going to turn my paper, and Y is the midpoint of BC. So I'm going to connect Y to which vertex? A. So connect the two dots. And what are these called, these lines that I'm drawing? These are called the perpendicular bisectors, altitudes, medians. These are called not the altitude, sorry, the what?
Medians.
The medians. I'm looking for where it says it up here. Medians. All right. Last one, I'm going to flip it around this way, and I'm going to connect midpoint C to which vertex? Midpoint Z to which vertex? B. All right, so this is very similar to what we did in notes. The difference is when we did them in notes, we used construction tools. We used our compass to find the midpoint. You see all the markings there that we have? There were no ordered pairs. So this is a picture of your centroid. It's right here, the point of concurrency. We just did it again, but without using the construction tools, we used graph paper. We used coordinate points. Okay, did they all intersect at one point? Okay, so they asked us to call this point D. So this is your final answer. I want you to count over and up to find what point do they all intersect. What is point D? Count over and up. What do you get? 1, 2, 3, comma what? 1, 2, 3. Okay, it's not always going to be that way. It's not always going to be like 4, 4, 5, 5, 3, 3. All right, so this is your answer, and this is your work, as well as the work on your picture. Questions on that one? Got it? Okay, so what do you need to know for this problem? You need to know what the medians are. The medians are the midpoints connected to the opposite vertex, and you need to know your midpoint formula. After that, it's pretty easy. Do you agree?
Yes.
Okay, questions?